want to give you guys a flavor for the interactiveness of the product. This first use case is really one of our basic use cases that our customers use all the time. Some of our customers use this 1,000 times a week, but really understanding the application performance, trying to understand exactly when the network changes, what kind of performance impact it has. A typical deployment would be, or a typical issue here like this would be you have a customer open a trouble ticket. And they're saying, I'm having difficulty communicating from my offices in Chicago out to LA. And I'm trying to understand, it seems like the network freezes up periodically. I've got all kinds of performance issues. My data center guys are noticing it. Tell me what's going on. And from our viewpoint, this would be very easy. What you see here is a kind of a standard topology. This is one of our lab topologies, but to give you guys a little bit of an idea, each one of these different colors is an OSPF area. So think of this as different pops within the network. Then they're all connected here with the backbone here in dark blue that's pulling them together. Now, what we'll show here is just adding a typical source and destination. So I want to now be able to select Chicago and LAX. And as I see that, it'll actually highlight my path for that particular traffic. So in this case, it's going from this device. The dark green arrows are showing me my forward path. The dashed green arrows are showing my return path. And if you'll notice these little tunnel icons, they're pointing out that in fact this return path is being controlled by a TE tunnel, not just the IGB protocol that's running in the network. That can be critical if you're trying to troubleshoot, especially if it had been an asymmetric path or something else. Now, what we're seeing here is at the time that I pulled this up, everything's looking good, but the ticket was open 30 minutes ago. So we need to go back in time and see exactly what was happening. I'll just simply adjust the time up here. And then as I do that, we actually move the entire model back to that time to see exactly what the state was at that particular issue. So we can see here that there was an adjacency. That's what these little red lines mean, that there was an adjacency failure, and that the network had rerouted. So it did recover, but as it was rerouting, it's going now from Chicago out to New York, out to DFW, back to Chicago, and then out to LA. So you can imagine that's going to increase your latency at a minimum. But let's drill in to the service to see if there's other impacts as well. So as I hit the drill in button here, we actually are taken to a view of the good path. So here I'm looking from Chicago directly to LA. Here's kind of the latency that we've been able to layer on that. It's also colored by utilization. So we can see between Chicago and LA, that wide area network, transport leak is taking some traffic. They're showing it's below 50%, but it is in yellow. We're going to hit the play button, and we can actually play through the set of events to see what happened. As the network plays, what we see is here's our previous path here in gray, and our new path here in green. So here's that path as we're shifting from Chicago out to New York and to DFW. And we can notice that the latency, it's added some additional hops, but latency isn't so bad yet. We'll continue to play this. We'll actually see the impact of the traffic as it moves over. We see the congestion hitting on this particular link between New York and DFW, and we see the latency resulting from that shooting up, causing all kinds of performance issues and those network freezes for that customer. We can actually drill in and say, oh, here's where it went from a normal utilization here in the 40 to 50% all the way up into the 90%, and we start seeing all kinds of congestion, drops, loss, and errors on the network caused by this. Now, for our model, this gives you a very quick way to see how we can help you understand how the service impact for when there was a change in the network, actually be able to go back in time to see what the root cause was. But we'll also show in some of my planning examples how we can then go in and see how we could rectify this at this particular time of failure.